Hi guys, welcome back to Springboard 3.1. Sorry for an interruption. So last time we stopped for distributed property right here. And again, if you want, you can show work how you multiply it. You can just show a nice green arrow here, saying that you're doing this turn. And that's how you get 6x plus 3. Alright, so the next property, we talk about reflexive property. Reflective property, if you look at it, is just a simple A equal A. So example of this, when you use it, is like this. You have x plus A equal 5. And let's say that was given. But you want to add something to both sides, but there's nothing in there. So you can say y equal y. And that's a reflective property. And you just want to show that you want to combine this to that. So you combine them together, so you did an adding property. So x plus y plus 8, and then y plus 5. For that one, you probably did some addition property. Yep. So that's an example of doing something with reflective property. For the most part, if it's the same number equal the same number, or a letter equal the same letter, reflective property. Alright, let's talk about transitive property. Transitive property and substitution property. It does the same thing, but depending on how you set it up. If you have A equal B and B equals C, then you're supposed to know that A is equal to C. So if you see A equal B and see B equals C, you're supposed to be able to link it up like a train here, saying, alright, these two are the same. This one connects like that. Therefore, then you know that A is equal to C. So let's say there's two given problems here. A equal 8, and then you have A equal Z. So these two are given. And then you notice that, hey, these two are related. So therefore you know that A is equal to Z by transitive property. Okay? I'll come back to symmetric property soon. Let's talk about substitution property. This one says if A equal B, then A can be substituted for B in any equation or inequality. So typically we see something like this, A equal B, A equals C. Notice that this is lined up right here. You know, compared to this is across, this line up, then you can just say, alright, then we know that B is equal to C. And here's some given example. A equal 8, and here we have B equal 8. Let's say these two are given information, and this is not going to be transitive, it's going to be substitute, just because these two are lined up. So that means you know that A is equal to B. So here you say substitute property. This one you want to spell out the whole thing. If you just spell S or B, sometimes you think that's subtraction. Let's go back here. Symmetric property, also a good one. Basically, if you have A equal B, then B is equal to A. So example of problem is that when you solve a problem and somehow you have X on the right side, let's say that was the given problem, but you want to make it look neat and nice, so you want to switch the whole thing. You take this X and bring it to the left side and 11 to the right side. Just flip the whole thing. So S equals 11. So here we just call that symmetric property. Okay? Alright, so let's do some example 1 and see how you do. Okay? So right now, what we want to make sure you understand is that to do a two-column proof, you want to be able to do a deductive reason right here. Okay, and you want to have a starting point, and you're going to make a number of assumptions that you know for sure that are true. So you do it without the proof, okay? But you just know it happened to be that way. So let's say you have this given information. So let's just set it up nice and clean. On the left side, we're going to call that statement. On the right side, we're going to give a reason why this is true, and we're going to justify it. So here we have 4x plus 9 equal 24 minus 1x. We know that was given because that's a problem given to you. To solve it, we're going to go ahead and get rid of the x here. The one on the right side, one on the left side, so we're going to get rid of this one. So we're going to go ahead and add an x to both sides. So here we have 5x plus 9 equal 24. So here we did addition property. We did plus 1x to both sides here. Now, if you still get confused with it, then you're more than welcome to do the plus 1x to both sides here, just to show that this is what's happening. Okay? But most of the time in two-column proof, we never see this. You just know that, oh, what's happening, this is what's going on. After you do that, to go from here to the next step, you're going to have to get rid of a 9, so you minus 9 both sides. We get 5s equal 15. So here you did subtraction property. So you have minus 9 to both sides. Again, you can show it if you want, or to keep you from being confused. So here you minus 9 to both sides here. Then after that, you're going to go and do what? You're going to divide both sides by 5. So here you're going to do division property or divide property. You're going to divide both sides by 5 here. That one will give you 3. And again, if you want to show work or show people what's going on, you can just go ahead and set it up here. Up to you, but most of the time that green color you see, the brown color you see, those are what you usually see. So what I want you to do is try the next example on your own. Let the teacher take a look at it, but if you're confident, you can go ahead to the next video.